This is the last section where we're going to talk about money, and to finish up this chapter we'll look at annuities. An annuity is a specified number of equal periodic payments, and payments are made at the end of each period, and that period is also the compounding period. One place where you might see an annuity is with a lottery jackpot. A person who wins the lottery can choose to accept a one-time lump sum, which is lower than the advertised jackpot amount, or to receive the full amount paid out over a number of years as an annuity. The cost to the lottery is actually the same either way. If the winner chooses an annuity, then the lottery buys one from an insurance company for the lump sum. So the annuity accumulates some interest from investments that the insurance company makes, and that brings the total payments up to the winner up to the full amount of the lottery jackpot. Another common use for annuities is for saving for retirement. Tax-deferred annuities are one way that people save for retirement. So the person pays money into the annuity before they retire. It's kind of like a savings account. And then they get the money back in periodic payments with some interest for a specified period of time after they retire. So this is the formula for the retirement annuity. And you can think of this as the reverse of paying a mortgage. So if you want to have M annuity payments per year of D dollars for T years with a constant interest rate of R, then you'd need to put P dollars into the annuity. So this is a lot like the loan payment formula from the last section, but it's been flipped around to find P here instead of D. So this is the same fraction but upside down, and we've got P on this side and D on this side. So let's look at an example of using that formula. Suppose that your father wants to retire at age 65 with an annuity that pays $1,000 per month for 25 years, and that he is willing to assume that at retirement the long-range steady interest rate will be 4% per year compounded monthly. What amount should he expect to pay for such a stream of income? So you want to know how much he needs to put into the annuity before he retires to get out $1,000 a month in monthly payments. So D is the monthly payment amount he wants, which is $1,000. R is the expected interest rate, which is 4%. And 4% in decimal form is equal to 0.04. M is the compounding period, and we said this is compounded monthly, so he's going to have 12 compounding periods per year. And T is the length of the annuity, and he wants to get these payments for 25 years, so T is equal to 25. So I can go ahead and stick that in my formula. So I'm going to have 1,000 times, and this time on the top I'm going to have 1 minus parentheses 1 plus R divided by M is 0.04 divided by 12 to the power of negative M times T, so negative 12 times 25 divided by R divided by M is 0.04 divided by 12 on the bottom there. If I put that into my calculator, that's going to be equal to, I'm just going to squeeze this on the bottom here, $189,452.48. So that's the amount that he needs to save up to put into the annuity before he retires if he wants to get out payments of $1,000 a month for 25 years. There are some issues with this type of annuity. If you live longer than the term of the annuity, then the payments will stop and you will have no further income from the annuity. On the other hand, if you die before the annuity runs out, then your estate will get payments due after your death, but it won't have helped with your living expenses while you are alive. So here you have to kind of try to guess how long you'll need the annuity for. There is another type of annuity that avoids these issues, and it's called the life income annuity. In this type of annuity, you receive a fixed amount of income per month for as long as you live. So how much you receive per month is based on the life expectancy of a person your age. So in this case, the company that pays the annuity is expecting that they will pay out the same amount on average that a normal annuity would pay. Some people will end up getting more if they have a long life, and some people will end up getting less. So in this example, we'll look at a life income annuity. Suppose that your 65-year-old father is retiring with $250,000 in a life income annuity. So he's managed to save that much up for his retirement. According to the table from one particular insurance company, he would receive $6.3448 per month for every $1,000 that he has in the annuity. At age 65, his life expectancy is about 17 years or 204 months. If he lived exactly that long, how much would he receive over the life of his annuity? Well, first let's figure out how much he's going to get each month. So he gets a monthly payment, which we'll call D, is $6.3448 for every $1,000. So we're going to times the total amount in his annuity, which is $250,000, divided by $1,000. So his monthly payment is going to be $1,586. So that's the amount he'll get each month. Now we want to see what he's going to receive over the life of his annuity if he lives for exactly 204 months. So his lifetime payments are going to be equal to 204 times his monthly payment of $1,586. So over the life of the annuity, he's going to get $323,544. So that's a pretty good return on his investment. He's invested $250,000, and in the end, he gets $323,544 out. Now, in this example, we're going to look at a woman retiring. So suppose that your 65-year-old mother is retiring with the same amount, $250,000, in a life income annuity. Women have a longer life expectancy and so receive lower monthly payments. She would receive $5.9010 per month for every $1,000 she has in the annuity. At age 65, her life expectancy is about 19.72 years or 237 months. So if she lived exactly that long, how much would she receive over the life of her annuity? So again, we're going to figure out the monthly payment. And that's going to be equal to 5.9010 times 250,000 divided by 1,000, and she gets $5.9010 for every $1,000 in the annuity. So her monthly payment is going to be $1,475, which is slightly lower than what it was for your father. It was $1,586. To calculate her lifetime payments, that's going to be the number of months that she's expected to live, 237, times the monthly payment, $1,475. And her lifetime payments is going to be equal to $349,575. So over the life of the annuity, she gets a little bit more money because she's got a longer life expectancy, but a slightly lower monthly payment. Things you should know for this section: you should be able to find the amount of money you need to put into an annuity to get a specified periodic payment. And you should understand the issues with a fixed term annuity and how a life income annuity addresses these problems.